Hello, I'm Keith Edmiston. I'm a professor in the crop science department at North Carolina State University. In my class, at the first of the semester, I asked my students to look online and try to find concerns about genetically engineered crops. I tell them to find at least one concern for developed countries and one concern that's more pertinent to developing countries. One of the most common concerns that the students come up with for developed countries is superweeds. So that sounds a little scary, and some of the images you see online make it look pretty scary. So what is a superweed? Here's a picture of a resistant weed online, or a superweed. And it looks really big. The people in the background look very small compared to this weed. And this particular weed is horseweed or mare's tail. Um, it is a pretty common weed in North Carolina and in a lot of areas of the United States. Now, you can see that on the left, the weed looks gigantic and scary because of the camera angle. On the right, there's a typical looking horseweed, and it's not quite as scary looking. Now here we have horseweed. On the top left, this is a susceptible horseweed. It's not resistant to Roundup or glyphosate, and I'll just try to refer to it as Roundup. Um, Roundup is off patent, or glyphosate is off patent, and there are a lot of different sources to buy glyphosate from, but the one that everybody knows about is Roundup, so I'll call it Roundup. And you can see that plant on the top left is rapidly growing. It's light yellow at the top because it's growing so rapidly. Then right beside it on the top in the middle, you see a lower rate of glyphosate, or a 1x rate, and it has pretty much killed that plant. And then a high rate has totally killed it. Then we look at the horseweed on the bottom right, and that is a resistant horseweed. The first thing I notice is that compared to the top left, the susceptible one, it's a little bit stunted looking. It's not as big. And that's a fitness penalty. Because of the resistance, it's not some superweed. It's actually smaller than the susceptible weed. However, it is resistant to Roundup, and that's certainly a concern. In the middle, on the bottom, you can see that a 1x application of Roundup, or recommended rate, didn't stunted it, certainly, but it did not kill the horseweed. And even at the 4x rate, although the plant's severely stunted, it looks like it's still alive. Now, in this graph here on the left is the amount of Roundup that's been applied. Uh, and you see that really takes off about 1997, when we first really got into growing genetically engineered crops that were resistant to Roundup. And once we started doing that, you see on the right axis, that red line is the number of glyphosate resistant weeds, or Roundup resistant weeds. So certainly once we started using the herbicide a lot, we saw increase in the number of cases of weed resistance. Now, if we look at a lot of different herbicides, weed resistance is nothing new. And although the popular media, and you see online, calling it superweeds, that is a relatively new term that came out in the media and in the anti-genetic engineering campaigns. It's not a term that was used in the scientific or the agricultural community. The term we use is weed resistance. So you can see here that the triazines came out pretty early, and in the blue line there, and once we started using triazines, we started seeing resistance. Same thing for the ALS and inhibitors. These are different classes of herbicides. And the blue one there on the bottom right of the graph is glycines. That would be for Roundup. So they didn't really start until we started using a lot of Roundup with genetically engineered crops. But certainly weed resistance was a problem before we ever used genetically engineered crops. And it's been a problem with all different types of classes of chemistry in herbicides. And in fact, here is an example of a weed that was resistant to a soybean herbicide prior to genetically engineered crops ever becoming commercialized. The weed you may have heard about the most is in this picture here, and that's Palmer amaranth. It's a type of pigweed, and Weather Max you see on there. It's received applications of Weather Max, which is a form of Roundup, and that has not stopped the weed. It's also received Staple, which has nothing to do with genetically engineered crops. It's a conventional herbicide. And before we ever had genetically engineered crops, we had pigweed that were resistant to Staple. So this whole idea is nothing new for genetically engineered crops. It's something we've had to deal with in agriculture for a long time. Here's another example. This is Roundup resistant on the right. In Union County and Stanley County, you see Roundup resistant ryegrass. On the left, you see susceptible ryegrass in Johnston County and Edgecombe County. And in that case, you could kill the ryegrass with a 1x or a recommended rate of Roundup. Whereas the resistant ryegrass, you needed to use very high rates to kill the ryegrass. So certainly that would not be economical, and people would not use those higher rates, and it would be off-label. So people don't do that. This was a research project. So this ryegrass, we had seen resistance before genetically engineering ever came out. And this is in wheat, and there is no commercially available genetically engineered wheat. This ryegrass is resistant in this case to ALS herbicides, and on the left this wheat field was treated with ALS herbicides, on the right with another herbicide that the ryegrass was not resistant to, and you can see all the wheat out there. On the left you don't see much wheat because the ryegrass outcompeted it. So again, weed resistance that occurred prior to genetic engineering with one of the same species that we hear about in genetically engineered crops. So how does this herbicide resistance occur? Well, it doesn't happen magically. It's not lightning hits a plant, makes it mutant or anything like that. Those genetics for the resistance occur somewhere in the population, probably at very, very, very low levels. But you spray a field with a lot of weeds in it, and one of those biotypes is resistant, it survives, and then you go to the right, it sets seeds. You go down to the bottom left, you have a few more resistant plants. If you continue to use that chemistry, that same herbicide or very similar herbicides over and over, you eventually will get to where your weed population is mostly resistant. So that's how it occurs. Herbicide resistant weeds are not unique to the United States or unique to areas of the world that grow genetically engineered crops. You can see there in Europe has a good amount of herbicide resistant weeds. I thought this was interesting. This was last year's North Carolina Weed Science Society meetings, and this is the program from the morning session. And you see resistance mentioned there several times. If you look at 1040, there was a talk about orchard resistance management. There are no genetically engineered orchard crops in North Carolina, but weed resistance to herbicides is still a problem. Same thing at 1055, turf resistance management. There are no genetically engineered uh, turfs that are resistant to herbicides that are grown in North Carolina, but they do have resistance problems. And then at 1110, I had to talk about resistance problems with Palmer amaranth and sweet potato. Now, there is no genetically engineered sweet potato. Uh, there is no Roundup resistant sweet potato. This is talking about other herbicides and resistance problems in sweet potato that have nothing to do with genetic engineering, just like the turf grass and the orchard management. Then we had to talk about resistance in aquatic environments, and then finally one with corn, soybeans, and cereals. Now, certainly the talk with corn and soybeans dealt with some resistance problems that are unique to genetic engineered cropping systems. But the cereals have resistance problems too, and the cereals are wheat, oats, barley, rye. None of those do we grow any genetically engineered uh, cereals. So those would have been herbicide resistant weeds to just conventional herbicides. Probably everybody's familiar with antibiotic resistance and how there's been some emphasis to try to not overuse antibiotics and rotate antibiotics. And certainly we do the same thing with growers. Growers have learned a lot about resistance. Um, and certainly now they use other chemistries to help to prevent and deal with herbicide resistant weeds. So the take home message, I think, is that superweeds is a new term, and it's the same thing as resistant weeds. Weed resistance happened a long time before genetic engineering. It's something we've been dealing with in agriculture since herbicides began to be used. And lastly, weed resistance is a result of an over-reliance on a pesticide. It really has nothing to do with genetic engineering. Thanks for watching.